Hello, everyone. I am Vaughan. I'm one of the co-founders of a team called Butter. I was invited here to talk about Futarchy, or Futarchy, depending on how you pronounce it. I'm British, so I weirdly say Futarchy. I don't know why. Really, my goal here is just to try and give you some basic concepts so that by the time that you leave here today, you have like a fairly good intuitive understanding of what we mean when we say we're going to make decisions using prediction markets. Quick hands in the air for anybody who thinks they do understand what Futarchy is and how it works. Excellent. Okay, so by the end of this, I'm going to ask again, and we're going to have loads more hands in the room, up in the room. Here we go. So notice I also said Futarchy and conditional funding markets, which is the implementation of Futarchy that we're working on at Butter. First up, so we're going to be talking about probability a lot, so I'm going to do this thing where I keep splitting the screen into like different worlds, right? These are like worlds we could like probabilistically inhabit at any time. So, okay, HDMI is broken. This is going well. Let's try again. Anyway, I'm going to keep speaking. So we have this world where we definitely want something. So positively, we want to fund public goods, but it's going to be a battle, apparently. We want to fund public goods, but we have a complication, which is that we don't know which goods to fund, right? Beforehand, we don't know what the actual amount of good will be for each producer, and so we end up with this problem where we could distribute funds anywhere, and we could end up funding the wrong things, right? This is kind of a classic problem of public goods, apart from the kind of free rider problem. So we have this kind of initial problem. So we don't know which goods will produce the most good, right? So how do we figure that out? So the problem we have, or the way we've kind of solved this in retro, with retro funding and retroactive goods funding, is to basically say, well, in the beginning, we kind of think that an idea sounds useful, but we don't know. So how about we just wait until we have more information, so we just let the project do whatever they're doing, and we get to some point in time when we know that the project is useful. It's producing some good that we think is good, and we are going to try and avail ourselves of that good. So over time, we basically figure out that a project is useful, and then we can fund that. That's great, right? So we've just avoided the problem entirely, but we just wait for the goods to materialize, and then we fund those. Sounds good. All right, I'm clicking so you can see the next slide now. And then the next slide, I just show you a big red area on the side, right? And that's where we can actually fund the projects. But now we have this huge amount of projects where they haven't produced enough information yet such that we know that they're worth funding, right? And this is a problem. I call it, here we go, it's looking good. You should see this slide, it's great. So let me see if I can make it. Oh, great, we are live, guys. So the red area is the area where we can fund projects, right? This is great. We're funding things retroactively, but we have this like area here. I don't know where I'm pressing. I might just retire. I might just give up. So then we have this big blue area. Here we go. And in the big blue area, we have this like this amount of time where we just can't fund the project because we don't know enough, right? I'm kind of calling that the chasm of opportunity. We can't fund anything if we don't know, and so we have loads of projects where we don't have enough information, and this might be where all the exciting work is, right? So another way of thinking about this is, am I aiming at the laptop? If you just press the next button when I ask, that'll be fine. So one of the problems is, if we think about all the projects that might exist in this world, we don't have enough information about them, they haven't done anything such that we can fund them retroactively. Another way of thinking about that group of projects is that there are maybe some of the best projects in there that produce the most good. But the problem is that they maybe are just too risky. Maybe they're just going to take too much money to fund. Maybe there's just too much cost. It's going to take too much time. And so if you think about RPGF being able to fund all of these projects that are like lower risk, that can kind of just work in their own world, trying to figure out what to do, producing the goods, and then coming back to the mechanism saying, hey, I did some good, please fund me. We're kind of missing out on all of these projects that are much, much higher risk, but could be things that are really, really useful. So I've said here 2 examples, and this is kind of outside of like crypto. Like nuclear sounds useful. We think it's going to be really useful for the world. So maybe we want to fund this. Maybe it's going to produce a lot of public good in terms of very, very cheap energy. And then all the way on the right, we have like malaria nets. And we know that the EA community was a big fan of funding malaria nets because they have this kind of, they're like low risk and they're super cheap and you can kind of get an instant feedback loop on them and you know you're going to get some good. So this is kind of a problem because we really might be missing out on some of the most like seismic, life-changing, like world-changing projects that could create a ton of public good. I'm gonna go for the next slide now. Okay, so I think I just have a delay. So the thing on the left is a prediction, right? We're predicting that nuclear would be useful, right? Not necessarily useful, but we're just going to predict that. We don't know for sure. And on the other side, we have malaria nets, which is an observation. We can look at malaria nets and we know how useful they are. We could probably calculate if we put $10 into malaria nets, we're going to get a certain amount of expected value back. Brilliant, right? So, okay, so now to bring it back to crypto, we could say conditional funding markets, which is our mechanism, the mechanism we're working on, sounds useful. We don't know yet. We haven't built it. We haven't deployed it. We can't apply for retro. We won't get paid, right? So if you look at retro PGF, we know about this mechanism. It's live. It's working. We're seeing the effects. We know it's useful. It's an observation. So what we can start to think about is this like multiple worlds problem. So on the left, conditional markets sound useful. Prediction. And now we have these two worlds. There's a world where conditional funding markets are useful, and there's a probability we're in that world. There's a world where conditional funding markets are not useful at all, and there's also a probability we're in that world. But there's this kind of observation that RetroPGF is already useful. So we're kind of very clearly in a world where RetroPGF has provided some utility. So we have this problem, which is, though we can get together to decide whether RetroPGF is useful by just observing the things that it's done already, how do we make a decision collectively that conditional funding markets are useful? And I'm pretty sure none of you will be able to opine on this because very few of you even know what conditional funding markets are, right? And so this is the problem. So let's say I could say to you today that 75% of the time, conditional funding markets are going to be useful, and maybe 25% of the time they're not going to be useful. I'm just kind of pulling these numbers out of my head, but you could kind of see why like, I personally can make that prediction because I have some information, and none of you can opine on this because you have none, right? So this is an interesting way of thinking about the problem of figuring out what to fund proactively before we have information based on predictions. So to kind of cut back to an experiment we ran last week in Chiang Mai, we asked a bunch of people to come together and select a whole bunch of problems, or just write down a whole bunch of problems that they thought DAOs were running into. They produced this list. Some of the people who worked on it are in this room. And then what we asked people to do, sorry, that's my anime podcast. So we asked people to kind of go through this list and come up with these problems. And then we asked people to vote on the ones that they thought were the most valuable to work on, right? So people just put votes down. So this is people actually making a prediction. They're using a vote to signal their prediction of which things they think will be valuable to solve. The next day, we asked people to bid on these proposals. So we said, we had proposals that were solutions to these problems, and I want you to bid some amount of money on the basis that if the proposal gets executed and it creates some value for the DAO, you're going to get to privatize the return, right? So basically, you're going to bid, and if it was really successful and it creates lots of money, you're going to get the money. And the bids were very different from the votes in lots of places. One of the most interesting ones is voter apathy, number 12, where we had 5 votes and we had like 1 bid. Like someone bid 1, one person bid 1. And so the idea here is that people will, even the same group of people, will make very different, give you very different information, make very different predictions if you give them a different mechanism by which they give you information. Okay, so I'm going to hopefully go to this. So bidders have an explicit stake in the outcome. If they bid and they're wrong, they lose money. If they bid and they're right, they make money. They're self-incentivized, which we all are, and we know that if they have a stake in the outcome, they will produce different information to if they're just voting. So the kind of insight here is that we can use markets as information aggregators for predictions because of this kind of principle I just described. Like when someone has an explicit stake in the outcome, they will change the way that they provide information to try and maximize their return. So let's say I take $1 and I put it in a contract, right, like a smart contract on chain, and I say this contract will pay out $1 if a candidate wins, if candidate A wins, and it will pay out $1 if candidate B wins. if you believe that candidate A will win, you're willing to bid up to 99 cents to buy that contract because you can make a profit, right? If you believe candidate B, then the opposite is true. And this is interesting because that means that people, and also if you believe the opposite, say candidate A is like, it's worth $1, you'd be willing to sell that contract down to like 0 if you don't believe it's going to happen. And so this is a really interesting idea that pretty much every single market is doing this job. If someone has information on whether something is likely to happen, they are willing to sell that information to the market. And when they sell the information to the market, right, to buy the contract, for example, they change the price. And so you can use this idea of like this $1 contract to basically show you the probability that people expect some event to happen. And this is kind of the fundamental idea behind prediction markets, which is what we're talking about. And if this clicker works, I think I'm going to take over 10 minutes because of the length, so I'm really sorry. But as I said, the prices can begin to reflect the actual probabilities. What people are saying, if the price is 49 cents, is that 49% of the time, they expect candidate A to win. If you actually believe it's higher, then you are incentivized to buy all the way up to that point that you think the probability is, right? Because you expect this contract to pay out $1. And in the event that it's 51 cents, then obviously candidate B would win. And we can take this principle again and apply it to markets as information aggregators for decisions. And we can say, I have $1, I have it in a contract. The contract will pay out if conditional funding markets, in our mechanism, increases ecosystem retention by over 50%. Let's say ecosystem retention is some metric. We were talking about the problem of metrics earlier, and maybe the Goodhart problem of metrics. But let's say we used ecosystem retention. We could use this to say, does our mechanism actually increase ecosystem retention by 50%? If it does, this contract will pay out $1. If it does not, and it just pays out, if it produces less than 50% retention, the other contract will pay out $1. And we can end up with prices, so we can go to prices, where 70% of the time, so people are willing to pay up to $70, 70 cents for that contract, which tells you that 70% of the time, they believe that that contract will pay out $1, which means that 70% of the time, they believe that conditional funding markets will increase ecosystem retention by over 50%. Does this make sense? Am I building a cohesive? Okay, great. And 30% of the time, obviously, the opposite is true. Right. So that means we can actually use this to make a decision. We can say, if we genuinely, if the world is aggregating all their opinions, all the information in the room, right, is coming. If, like, for example, if you agree with this, you might decide that you want to buy the smaller contract, right, the second contract, because you know you're going to make money. If you believe that the lower contract is actually going to end up paying out $1, because our mechanism will not produce the actual goal. So we can just select that decision. We can use this to make decisions. And this is the kind of like insight behind Futarchy, and decision markets, right? As a kind of another primitive that you can build on top of prediction markets. So we select it, and then we run the experiment. We actually select conditional funding markets, we deploy them, and hey, they actually increase ecosystem retention by over 50%. We've won, right? So this is a really, really strong case for Futarchy. And just to kind of double down on this, the kind of explain it like I'm 5 is, if markets believe that the outcome you want, given decision A, is more valuable than the outcome you want, given decision B, select decision A. This is actually how we all make decisions. Right? Should I bring an umbrella to Bangkok? I'm going to look at the forecast. The forecast says, yeah, it's going to rain. Okay? Like, if 70% of the time it's going to rain, I probably want to bring my umbrella. Right? So I have a bit more, but I don't think I'm going to go through. I'll go through it very quickly. So say, for example, we have a proposal. This is in the Uniswap forum. This is for Tally. They're like one of the most important governance service providers in the market. They produce an entire delegate platform for voting and making proposals. It's great. And they recently put a proposal to the DAO saying, will you fund us, basically? Will you pay us for the good that we're producing for the ecosystem? And people are voting on this right now. It's $250,000 a year. And the kind of mechanism here is that people make a proposal, there's a discussion, there's a vote, and then the funding is released. So in the vote, people are aggregating their signals. And what we really want to do is we want to just figure out if the proposal actually increases the value or produces a lot of public good for that ecosystem. And the question is, does the vote actually do that, yes or no? So the thing I was going to say here is that every single person in the DAO is dangerously long themselves, right? They are very self-interested, and so this is what's driving the decisions. This is what's driving the vote. So if Uniswap fund tally, does this create more public good for the Uniswap ecosystem? With conditional funding markets, the way that you would run this would be slightly different. So what you would do is, you would have an objective, you would have submissions, you would end up with predictions, which is people buying and selling these contracts. That would produce probabilities, and you'd use this to actually make the funding. And then what you do is you wait and observe, and at some point in time, you would get the event. Either Tally being funded produces this growth in public good or not, and then you can actually do the payout, right? And you pay everybody based on the contracts they own. So the solution here is long Vaughan equals long public good. And this is the idea of Futarchy, is that it ties the direct incentives that everybody has to the actual outcome you want, rather than to the spurious incentives that drive most of our behavior when we vote. Sorry, it's been very long, and thank you everybody for withstanding the issues. Thank you very much.